I said, this was before the sort of AI boom. What we're starting to realize is this is driving much more data center use and much more emissions. And it's starting people to realize that we've probably been getting this wrong, and it's starting to reach the headlines. We're starting to get people to realize that we're massively underreporting our cloud emissions and our AI emissions, and AI is the big thing that's driving that. In fact, that one in the top right, data center emissions is probably 662% higher than they're currently being reported. 7.62% higher than we think they are. Now, regulation can help change this for better or for worse, depending on your opinion. But hopefully you're starting to see there's a vague acknowledgement that we need to do something about this. And people are starting to ask, well, what's the big problem? It probably looks like AI. So most people naturally start thinking, can we have green AI? And to cut a very long story short, no. But I realize that's not a very good presentation, so what does the question really become? It becomes, can we have a greener AI? That ER in greener is doing a lot of heavy lifting in this talk. There's a lot of things that we need to think about and consider when we're making decisions in our businesses and our organizations today about how we adopt AI while remaining conscious of the environmental impact of the things that we're doing. And some people are already conscious of that problem. Luckily, I work for an organization that's already made its green software commitment. So Kainos is trying to be more sustainable in the software that we deliver. So this is on our website. We have our green software is more sustainable software. We're committed to reducing the energy impact of the software that we deliver. And we're starting to see other companies understand this, and we're starting to see other companies adopt similar approaches. But if doing it out of the goodness of your heart isn't enough, well, it's starting to hit regulation soon too. This is part of the EU AI Act. It's a tender that came out in August, where they're asking for things like focused frameworks and measurement for the emissions of AI systems. They want to understand appropriate governance and reporting standards that AI models are going to have to attain to, even if you're just using AI. And they also want to do things like labeling and promoting energy efficient standards and models that exist. You may think, well, it's just the EU. They tend to overregulate. Well, we're seeing it in a bunch of other places too. France and Spain already have mentioned this in their AI strategies, their national AI strategies. France have already legislated for this. In the bottom right, an interesting one is probably the US. We have a proposed bill, which I think is going on the floor next month, to talk about a voluntary reporting system for the environmental acts of AI. Although it's voluntary, it's still a start, right? We're starting to see this be a bigger and bigger driver. So what can we do? Is there stuff that we can already adopt? Well, Kainos has made this green software commitment. Is green software the kind of answer here? So what is green software? Green software is this idea of sustainable software engineering. This comes from the Green Software Foundation, part of the Linux Foundation, founded by a bunch of major cloud providers and technology companies, but really it's a charity that are trying to do a bit more here. And they define three main pillars about what makes software green. Carbon awareness, energy efficiency, and hardware efficiency. I've put some headlines in here, but to explain what each of these mean. Carbon awareness is doing more when electricity is cleaner and doing less when electricity is dirtier. That's really about accepting the emissions and accepting the intensity of the grid at any given time. So understanding what your software is emitting at any point. It's about taking ownership and accountability of the emissions of your software while it's running. Energy efficiency is about using the least amount of energy possible. So that's both doing things efficiently, which is great, but the best way to think about this is, do I really need these systems as well? The greenest software is the software you never write. How can you think about making smart choices about using energy and using these tools in an appropriate way? And hardware efficiency, it's about using the least amount of embodied emissions possible. Embodied emissions, embedded emissions, this is the idea of all of the emissions that go into a device, that life cycle of it before it gets to you. If you take something like your mobile phone, regardless of how well all of you use it, how well you keep it and care for it and charge it at night, 70-90% of the emissions that that device will ever have will already happen before it gets into your hands. Hardware efficiency is about using it in the most appropriate way, maintaining its life cycle for as long as you can, and recycling and taking it to end of life as appropriately as you can. These pillars are really about accountability, awareness, and ownership. How are you taking that forward into your journey with AI? Well, if we look at something like an AI lifecycle, this is coming from Hugging Face, which I completely stole. They have raw material extraction, material manufacturing, equipment manufacturing. These are things you need to think about when you're building an AI system. You can't just say, oh, we're trusting OpenAI to do that. You still have a part in the emissions that you're creating. So we need to understand what that looks like. We need to understand the model development and training, model deployment and use. So what are you actually doing with the model? How are you training it? How are you using it over time? And then the disposal and end of life for that model as well, which is something that we all love to forget about and avoid. If I overlay those green software pillars, there's a lot of overlap here, but generally we're saying hardware efficiency comes at that start. How are we thinking about what we're using? How are we training things and where we're using them? Carbon awareness comes throughout its use. How are we using it? Are we accepting of the emissions? Are we tracking them over time? And energy efficiency is going into how we're building and maintaining that model. A couple of years ago, when AI was first taking off, people started talking a lot about inference being where the cost was going to be. Initially, the cost was in training. The cost is in training. The cost really comes over time with inference. We're starting to see the same thing with carbon emissions. Although the headlines are all these ChatGPT models take up so much carbon to train, the real problem comes over time when you're inferring over that model, over its life cycle, over its end of life. These emissions get really big the longer we use models. So what can we start to do about this? Some of you are probably thinking, well, what about offsets? We pay for offsets as a business. Yeah, that's our way out of this. Well, a lot of people kind of misunderstand what offsets really mean. If I think about reducing emissions, this comes from the Green Software Foundation, there's kind of two real tracks you can go down. There's the gold standard, abatement and elimination. Don't emit the emissions. And then there's offsets. The ideal, the goal, the sort of what we really want is this neutralization, which is taking stuff out of the environment, direct air capture. Unfortunately, these things aren't really at scale yet. We can do it as kind of science projects, but it's not quite there. So a lot of people just rely on this compensation and avoidance, paying someone, paying for these credits, paying for these offsets. And that's what the big cloud providers are generally doing. We have someone like Microsoft, not to hit on any cloud provider in particular, but we're not picking on Microsoft, who are saying, we're carbon neutral, we're net zero, we've achieved this. They have paid for all these offsets to achieve that status. Roughly 2% of those offsets have actually been met. So 98% of the emissions that they're responsible for are still being faced by all of us today. Only 2% of those emissions have actually been offset today. They have paid for it, they've said it's no longer my problem, but it doesn't actually mean it's no longer their problem. All of these offsets, all of these things take a lot of time to come through. If I go out and plant 1,000 trees, I'm probably not going to see any carbon offset from them from at least 5 years until those trees get to the scale where they can actually absorb enough carbon. People are kind of avoiding it by saying, oh, we're doing this, without really fully accepting that there's a problem here. We still need to take ownership of these emissions. We still need to actually think about how we move towards elimination and abatement as opposed to just paying the problem. When people start accepting that, they say, well, AI will get a lot better, right? We'll innovate our way out of this problem. So can advances in AI solve it? It's unclear. Although there's been some really good steps by people like Hugging Face, who are developing these kind of Energy Star standards for different models, where they're stamping things as being sort of climate friendly or climate approved. It's a good step. It's probably not solving the answer. We can't really wait for 3 to 5 years down the line of building all these AI models, producing all these emissions and saying, oh, we'll solve it down the line. The problem's still happening today. Although we're in the AI next track, this is still an AI now problem. We need to think about what we can do actually going forward to try and reduce these emissions and try and take more ownership of what we're doing. How can we think today about reducing our impact? So what can all of you do going forwards? Well, there's kind of 3 main areas that we can talk about. There's technical interventions, behavioral interventions, and organizational interventions. On the technical side, we've got things like the green software techniques. There's a bunch of standards, there's a bunch of templates out there that we can all adopt. And there's also more operational levels when you're going into building your models, things like pruning, quantization. I'm not going to dwell on those today. On the behavioral side, there's things like model selection of task-specific versus multitask. We can think about benchmarking. The big thing there is probably life cycle thinking. And then organizational, thinking about things like responsible AI and measurement. To go into some of these in a little bit of detail to show you what these interventions kind of look like, when we're thinking about measurement and KPIs, how do we actually measure the emissions of a given piece of software, a given model? There's a lovely ISO standard the Green Software Foundation have built for us. It's called SCI, Software Carbon Intensity. I've ran this with a few of our Gov clients and a few NHS clients, and it's hard. Although it may look like E times I plus M per hour, there is a lot going into those numbers. There is weeks of work behind each of those numbers. And it's a great place to aim for, but it's probably worth starting small. Think about an inference call. Think about one training cycle. How can you really break this down? The problem today lies in the fact that getting this data is such a challenge. So if I was to say one thing about your measurement approach, it's start capturing things today. How are you logging at a more granular level that will enable you to do this down the line? We're thinking about life cycles. I'm going to go back to my diagram I stole earlier. How are we thinking about what sustainability steps we're making throughout its journey? What are we thinking about each of those life cycle points that we're making smarter or greener choices? What are the actions and remediations we can take at each step? There's a bunch of examples out there. If you Google each of these steps with things like green software at the end, you will find a bunch of patterns that are already built by people much cleverer than me who will go into the detail of this. The other one is thinking about things like your software development lifecycle in general. Although AI is developed a bit differently, it's much more experimentation based. The software development lifecycle itself can still be greened or greener, and allowing you to take steps throughout that will help you reduce your overall impact. Another one to focus on is something like responsible AI frameworks. So hopefully you've all learned the importance of responsible AI today and at this conference in the past. If you don't have one, why do you not have one? And if you do have one, is sustainability part of it? How are you approaching sustainability when you're approaching responsible AI? What measures are you setting? How are you validating them? Are you looking at something like SCI? You can't really rely on people like cloud providers' dashboards. They're not really incentivized to help you get those numbers right. So what are the more realistic steps you can take? How can you start tracking things in an earlier level? I know it sounds a bit reductive, but to take an idea that you all hopefully all remember from the 2000s, reduce, reuse, recycle is probably the best way to think about this. This is a really simple way to actually think about this. It's a great idea. Think about reducing your energy use. Can you just, frankly, reduce your AI use? Kind of like I said at the start, the greenest software is the software you don't write. The greenest AI is the AI you never develop. Can we look at reusing existing models, reusing results? Can we look at just caching? That will save you massive amounts of carbon. It sounds like such a simple thing, but it will really reduce your impact. And recycling your entire solutions, right? Think about what hardware you're using, how are you using it over time, what end of life looks like, how are you increasing the life cycle of your systems beyond what you have today. To quickly wrap up, scrutiny and regulation are becoming bigger issues. You need to start thinking about your approach to greener AI today. There's no such thing as green AI. That's not an excuse for you not to approach this. Offsets aren't the answer. Unfortunately, we're not going to pay our way out of this problem. Think about life cycles, think about measurements, think about frameworks, and simply your 3 R's, reduce, reuse, and recycle. How can you apply that to green software going forwards? If I was to put this for practitioners and leaders, the 3 things I would say as a practitioner, think about raising awareness in your team. This stuff becomes ground up when you start talking about it in your teams, when you start taking awareness and taking accountability for it. Think about what those technical interventions look like, go into a bit of detail, look at is there something that you can apply directly today, and start measuring. Start looking at something like SCI for an inference call. It's going to be hard, but you've got to start somewhere. If you're a leader, think about how you enable that cultural change within your teams, right? How do you make space for your teams to actually think about the emissions and start taking ownership of them? There's really simple places to start, like green software practitioner training that takes about 2 hours and can really enable your teams. Think about reviewing a responsible AI framework. Are you actually setting sustainability as part of that? If not, come talk to me. And think about how you enable space for measurement and management of your emissions. That's everything, folks. Thank you for listening. There's my contact details if you want to get in touch. And finally, a few of us at Kainos wrote a book, I guess like a primer to sustainable engineering. It's called Digital Sustainability. If you want to reach out, I will hopefully get you a PDF copy. Thank you.